So 6, here we go. What we're going to do today is solve fractional equations. Basically, this is going to be a do-over of the complex rational expression lesson. It's the same steps, the same order, the same beginning. The only difference is once you get yourself settled, then you're going to have to like do some opposites and solve, like Algebra 1 stuff. Okay, so on complex day, that was the fractions in fractions, if you don't know what I mean by that. Where did we look on complex fractional expression day? Looked at all the bottoms. So we're again going to start off looking at all the bottoms, and we're going to pick a thing that we did a lesson on called LCM. So if we look at all these bottoms, what are we going to pick for our LCM?
Is that 5 or is that a...
That's a 3, a 6, and an x on the bottom. It would be 6x. 3 and 6 go into 6. X is present. So 6x is my LCM. What did we do with the LCM? What did the LCM accomplish? Two ideas that I'm trying to hit again. It's going to completely cancel the bottoms. So this is going to be able to completely cancel bottoms away, so fractions will be dead. And then what else does it do? Because there's usually leftovers. It multiplies. All the leftovers stop multiplies. So we're going to get something. This plus that equals that. It's just going to be no more fractions. It's just going to be leftovers that multiply. So let me start with this one because it's maybe easier. Here I get a cancel of x's,
6.
and we just get a 6. Here I get a cancel of 6's, and we get 5x. Here when 6 cancels 3, it leaves you 2 to multiply the other 2, as well as having an x. So we've got that. That's what makes this new. We're going to use this LCM. Cancel all those fractions, at which point you should be able to go, Algebra 1. Question about making that first bump. Okay, Algebra 1, what would you do?
Combine.
Combine, so x count?
9.
9x equals 6.
Divide
by 9.
2 over 3.
2 over 3. 6 would go on top of 9. Reducible, 2/3. That's a win. Question about that one. Idea stays the same. This next problem is just a little bit bigger. So again, we start off looking at the bottoms. Pick n, which is 20. Anybody bothered by, we're looking at the bottoms, we're picking a 20. If it makes you feel any better, this is invisibly
Under a 1.
with a 1, but that's not necessary to write that, but that's there. So when 20 cancels 5, it leaves you with 4. 4 has to multiply all that stuff. So you could either write that as a distribute problem, or you could distribute it. But that's going to make 4y minus 8. Anybody bothered by that? When this cancels this, it leaves you 5. So you could either write that as a distribute problem, or you could go ahead and just like distribute it, but also take note of this. This minus and this 5 have to make some changes, both.
What?
Minus 5y plus 25. After the equals, it's no longer a negative 2. These are doing what again? They're multiplying. So our total up?
Negative 40.
Negative 40. Question about that. That's what makes this new to your life as an Algebra 2 person. Although I do think you did this lesson in Algebra 1, like a little bit. I don't think it was like heavily hit, but I do think you did it. Question there. And then this is heavy Algebra 1 life. So if we go ahead and start off by combining your y count.
1.
Negative 1. Your number count is a positive 17. Then opposite count, subtract the 17. So the negative 1y, if we subtract 17 more, down to negative how much? Agreed. And then positive 57. Good old Pittsburgh number times 57. Question about that. Then here's something I should suggest even though I know in my heart no one will ever do this. Okay, check it. Okay, so if we want to check it, just plug it in. 57 minus 2, 55, dividing 5, 11. 57 minus 5, 52, divide 4.
Probably about 17. 16.
Somebody whispered it, I think. 13. 11 minus 13 is negative 2. That does check. You can always check. On a quiz, you might be more motivated to check. I don't know. On a homework, at least check the odds in the back. Make sure you're doing good stuff. Question about that one? Same process, just a little bigger problem. When we look at the bottoms, we're going to have to do something extra first on this. What are we going to have to do first to the bottoms? Factor. This is going to have to factor to pick an LCM. That happens sometimes. This would be x plus 3 and x minus 3. So that's out. Its friend is in. Parentheses make some people feel better. They're there whether we write them or not. But we again look at all of them. Bottoms, pick up.
X plus 3, x minus 3.
X plus 3, x minus 3. That's called for this problem the LCM. Anybody we saw, we take it. Why didn't I square this thing even though I saw some of them twice?
Because it wasn't in the same.
It was never in the same spot at the same time. Question about LCM picking? Okay, first fraction, real nice cancel. Who's left?
2.
Just 2. Perfect cancel of everybody. Just write down the 2 that's staring us in the face. 5 needs to make a friend. Who's 5's new friend?
X plus 3.
X plus 3. So you could write that a distribute problem, or you could just distribute it.
5x plus 15.
5x plus 15. Leave this alone, or 3 makes a friend.
X minus 3.
3 makes a friend with x minus 3 after our cancel, which will total
3x minus 9.
3x minus 9. Something about that. A little bit of cleanup. So 5x 17. First time today we've added a variable on both sides. Pick one, get rid of it. Who do you want to move? Move the 3. So to move a positive, subtract it. So 5 minus 3, 2x. While we're doing that, let's move the 17 because it's now in the way. Adding 17, you'd have to subtract 17 down to negative 26. Grand total, negative 13. Question about that before it gets easy? Question on any of those? If you have 2 fractions, one fraction equaling the other, I'm going to dust off an old skill that we've done before because it's easier than this whole lesson. So if one fraction equals another, does anybody have a memory of something we can do when we have a 2 fraction game in town? Cross multiply is correct. The 5 wants to distribute the x minus 4, which would make, agree, while the 7 multiplies the other thing and gets you,
7x plus 21.
that's correct. If you wanted to think through the steps that we were doing, it would be valid, but I think it's quicker to just think about cross multiply and just hit it and go. You don't need to think about LCMs. Let's get the x's over here. 2x. Let's get the numbers out of the other way.
Negative 40.
Negative 41. Grand total.
41 over 2 negative.
Negative, and it is 41 over 2. I agree. I'm going to just cross these out real quick because those weren't answers, those were just LCMs. And I'll leave that my answers circled. Question up to there. This I can go even easier than that. What about this one makes this problem different and in a way that's easier? The bottoms are the same. So if the bottoms are the same, what you could do is just get rid of them. Just go after the tops. If the bottoms match, just act like they were never even there and just try to solve this. This would get us 3. It would also get us negative 3. which if you'd rather write that with a fancy symbol, plus minus 3, that's all fine. Come on that one. So this, same kind of thing. We get
4, negative 4.
Agreed. I'll have one more comment, but before I do that, question about anything we did so far. So here's my comment, and then a question. Everything we did is right. We have not made any mistakes. There's nothing incorrectly done. Everything has been correctly done. However, one of these answers is wrong. How or can you swap
I'm gonna take a guess. It's the
who's got to go, or why does somebody have to go? How would you even know it had to go? But somebody's got to go. There's one outlier here of an answer that has got to go.
It's not the 57.
But it's not the 57. How do you know it's not the 57?
We checked that.
Because we checked it. So we're on a good path toward the conversation that I want to have.
Maybe a negative 40.
Maybe, but then my follow-up would be why. He's saying maybe one of these. So, I mean, let's try it out. If we tried out the 3, you'd get 9 on top of 11, versus over here, you'd get 9 on top of 11, so 3 work. If we put in the negative 3, 9's on top of 5. Over here, what's negatives squared? Positives, so that's 9 on top of 5. So those work. So is the problem over here? I'll say not on those. No, those work. We can check those. They work. That's fine.
It was the very first one. So it's like
Well,
the 230.
this one would be a little bit of a pain to check, but I mean, we can check it. If we were going to add these, you'd have to make common denominator. Somebody said 4/6. Add that up. That's 9/6. 9/6 reduces to 3/2. This symbol we can interpret to mean dividing. If 1 divides this fraction would flip. So would that work? Yeah. So check.
Oh, I said a negative 41.
Negative 41/2. I'll save you the time and bother. If we did check this, it'll work.
So it's the negative 13.
If we check this, it'll work.
So 4, negative 4.
It's one of those. One of these doesn't work. Can anybody, now that we're narrowed it down to this little corner, why does one of these answers have to be thrown away like
It's going to be
garbage?
over 0.
We don't, which one?
The one with the negative.
The negative.
Positive.
Positive. Yeah, the positive 4.
I'm hearing a lot of different things.
It's positive.
Positive 4. If we put in the positive 4, the positive 4 makes the bottom,
0.
and that is simply not allowed. Okay. So, do you have to completely check the whole problem to find those? No, but you at least have to make sure that your answers won't make the bottoms 0. So, who would have had to be a throwaway answer on this? Who'd have been our bad boy answer? Negative 8 would have had to been thrown away. But we didn't get that. This we'd have had to throw away negative 3's, or positive 3's, or both of them would have to get thrown away. These we'd have bad news from negative 3 or positive 4. This one's sort of weird because there's no bad news. Anything would be okay. This one, the only bad news number would be 0. If we got 0, we'd have to throw that away. If you got one answer and you had to throw it away, the answer is, at least on one of these problems tonight, maybe 2, that there is no answer. If you got 2 answers and had to throw away one of them,
That's the other.
then it's the other one. You keep the other one. So this is not a 2-answer question. This is a 1-answer question. This gets to be a 2-answer question. there is at least one or two in the homework that there are going to be no answer questions, because even when you do the math and you get it right, the answer you get makes the bottom 0, you have to throw it away. On a quiz, I would recommend, as your teacher in safety and most success, check your answers, try them out, make sure. But on the homework, at least make sure the bottoms aren't going to be 0, because that's going to burn you here. That's what I've got. Question about 6-6 information. The process is a total replay of the complex rational expression bit. It's just a matter of once you do it, you've got an Algebra 1 equation to solve. Okay, homework is 270. We have about 20 minutes left in our time together. We're going to skip our 3's, and this goes to 28. So skipping 3, 6, 9, 12, all that kind of stuff goes to 28. There's 1, 2, 3. There's 4 of them that have no answer, but some of them might be ones we skipped. So if you don't get 4, maybe it's because 4 of them I can see are no answers, but maybe they were multiples of 3 that we didn't bother to do. But if you don't spot any with no answers, something wrong happened, because we're definitely doing some of the no answer problems. For sure, for sure. Anything? Last call? That's it.